We're going to talk about writing ionic formulas with transition metal cations and polyatomic ions. If you have not already watched the video on crisscross method, then you need to go back and watch that first before watching this video. So when we're writing ionic formulas, it's pretty straightforward, but there's a couple of tricks and tips that you need to know to deal with transition metal cations and polyatomic ions. So the first thing you need to understand is that transition metal cations are polyvalent. That means they have more than one oxidation state. But it's okay because that oxidation state is always included as part of the ion's name. So for example, let's say that the ion name is iron, and then there is this Roman numeral in parentheses next to it. That means this is iron in its +2 valence state. So it's an Fe2+ ion. Alternatively, if it had said iron and then there was a Roman numeral 3, then this is iron with a 3+ state. The trick with transition metals is that you need to know your Roman numerals at least through number 10 in order to understand what the transition metal's charge is in the form that you're dealing with. And that way you can appropriately apply the crisscross method in order to write the formula for a transition metal compound. So let's say, for example, that I'm dealing with iron 3 and sulfur, so iron 3 sulfide. Well, so that means I'm going to have iron in its 3+ state, and then I'm going to pair it with sulfide, which is sulfur as an ion, and since sulfur is a group 16 nonmetal, we know that it forms a -2 ion. So now that I've established what my charges are, I just do the same crisscross method that the other video talked about. I'm going to take this number, and I'm going to take this number, and I'm going to swap and drop them, and I'm going to ignore. So I'm going to make these charge symbols go away so that I'm going to get 2 iron and 3 sulfur as part of my iron 3 sulfide compound. And since, these numbers are not divisible by anything, this is the lowest whole number ratio, I would stop there. So now let's talk about what we do when it's a polyatomic ion. Polyatomic ions are groups of covalently bonded atoms, but then they also ionize. They gain or lose electrons in order to fill an octet. When we're dealing with a polyatomic ion, we have to treat that ion like a whole unit. Now, there is a chart that is in Google Classroom for you with all of the common polyatomic ions that you will use as a reference for when you're writing these compound formulas. So, for example, let's say that my compound is sodium sulfate. So I already know what sodium is. It's Na, and it's a +1 because it's a group 1 metal. Sulfate, if I was to consult my polyatomic ion chart, it would tell me this. Sulfate is SO4, which means it's 1 sulfur and 4 oxygen. And the overall charge on the sulfate ion is a -2. Now, when I go to do my crisscross method for this, I'm going to take my numbers. I'm still swapping and dropping, but I'm going to drop this 1 to the outside of that parentheses that I drew around the sulfate. And then I'm going to drag that 2 and drag it over to the sodium. Notice I did not touch this 4 inside this parentheses. This 4 is the number of oxygens bonded to this sulfur to make this ion, and that does not change. So with the polyatomic ion formulas, you don't mess with the subscripts. So then when I go to write this, I'm going to have 2 sodium and 1 sulfate ion. And I'm going to take that out of parentheses because I really don't need the parentheses for if there's only 1 polyatomic ion bonding. So that would be my correct formula for sodium sulfate. But what do we do if it's going to be more than one polyatomic ion? Well, let's take calcium hydroxide as an example. For calcium hydroxide, well, we know calcium. Calcium is a group 2 metal, and so as an ion, it forms a +2 ion. If I was to go to my polyatomic ion chart and look for hydroxide, it is OH. So it's an oxygen and a hydrogen covalently bonded together, and it's a -1. That's a really bad one. It's a -1 ion. There we go. So in this case, when I go to do my crisscross, this 2 is going to come to the outside of this parentheses, and then the 1 goes over to the calcium. So that when I write this formula, I'm going to keep my parentheses, and then the 2 comes to the outside. And again, notice I dropped that 1 subscript because we don't write 1s. And you may have noticed that all of the polyatomic ions I'm using so far are anions. Now, that's because if you consult that chart, there's only really one polyatomic cation that we work with, and that's the ammonium ion, which is NH4, and it's a +1. So by and large, if you're going to have a polyatomic ion, it's going to be your anion in the formula. So I hope this was helpful in helping you figure out how to write ionic formulas with transition metal cations or with a polyatomic ion.